We are on our last day of factoring, and we have a couple of vocab words. As a reminder, this PDF is also on my website under section 5.3C, so you don't have to write all of this down if you don't want to. So the first vocab term is zero product property, and you know this property whether or not you've ever called it by its name. Basically what it says is if you are multiplying to zero, you must be multiplying by zero. So my example, if A times B equals 0, either A equals 0 or B equals 0. Of course, there's also the option where they both equal 0, but at least one of them has to be 0. Now our next two vocab words have very similar meanings. There's just one slight difference. First one is roots, and that's the solution to a quadratic equation. Quadratic equation is when you have an x squared function equal to 0. So my example, quantity x minus 3 times quantity x plus 5 equals 0. So the roots are 3 and negative 5, remembering the asylum, and we'll see how that works a little bit later. And the final one is zeros. That's the x-intercepts of a quadratic function. So notice the only difference between kind of my definitions on these two are this one equals 0, this one equals f of x. That's the difference between a root and a 0. All right, again, reminder, this is on my PDF on the website, and this is just a review of all of the different types of factoring that we've seen so far. And the process, anytime you factor, is the first thing that you look for is a GCF. If there's a GCF, factor it out, and then check for what's left. Can you keep factoring? We've factored binomials, difference of squares, trinomials with a lead coefficient of 1 and a lead coefficient that's not 1, and we've factored quadnomials, or 4 terms, by grouping. So we'll see all 4 of these as a review on the next couple of slides. All right, so as I said on the first page, the first step is factor out the GCF if there is one. So looking at my two terms, x cubed minus x, they've both got a common factor of x. Dividing that out of my first term, I have x squared, and x divided by x is 1. So make sure that you don't miss that part. That's a common mistake that I see when students factor. And then look at what's left. I think that's all we have. What's left in my parentheses is x squared minus 1. It's a binomial, so my only option is to check for difference of squares. Well, x squared and 1 are both perfect squares, so the way that I factor a difference of squares, I like to set up my two binomials. Square root of x squared is x. Square root of 1 is 1. 1 positive, 1 negative. All right, example B, look for a GCF. In this case, all 3 of my terms have a common factor of 2. Dividing that out of each term, I've got 2x squared minus 9x minus 5. When I factor a GCF, I typically check to make sure that what's left doesn't still have a GCF. I didn't do that on the first one because with x squared and 1, it's kind of obvious they don't. But 2, negative 9, negative 5 no longer have any common factors. So now I'm going to look at what's left. It's a trinomial. Lead coefficient is not 1, so that means I use my AC method. So I'm going to multiply a times c to get negative 10, what multiplies to negative 10 and adds to my b term, or negative 9. So remember, numbers that multiply to a negative and add to a positive, you have to have one of each sign. Sorry, add to a negative means the larger number needs to be negative. All right, so I'm going to drop my GCF for a minute, just so my work is a little bit less confusing, and I'm just going to factor what's inside the parentheses. So remember, with the AC method, we rewrite that middle term with that pair of numbers we found. So negative 10x plus x equals that negative 9x that it just came from. And then we factor a grouping. My first 2 terms have a GCF of 2x. When I divide that out, I get x minus 5. And my second 2 terms do not have a common factor. Well, if they don't have a common factor, it's 1, because 1 goes into everything. So now I'm going to look at the two terms that I have left. Notice they have a common factor of x minus 5. Dividing that out of the first term, I have 2x. Dividing it out of the second term, I have a plus 1. Okay, so what I have here is just the factored form of 2x squared minus 9x minus 5. So in order to factor what I started with, I'm going to bring this 2 down as well. So you can't lose your GCF when you have to factor and then keep factoring. We're going to look at two more quick. So step 1, do we have a GCF? Looking at all 4 of my terms, yes, they have a 4 in common. So I'm going to divide that out of each term. Sorry, that's 3. All right, and then you look at what's left, and can you keep factoring? Well, in my parentheses, I have a quadnomial, so my only option is to see if I can factor by grouping. So again, I'm going to drop my GCF of 4. Looking at my first 2 terms, I have a GCF of x. Dividing that out, I get 3x minus 2y. My second 2 terms, again, no GCF, so it's a 1. And finally, looking at the 2 terms that I just created, they have a common factor of 3x minus 2y, leaving me with x plus 1, and not losing the GCF that I factored out in the first place. Last example, sorry this video is running a little long. Look for a GCF. We have a common factor of 3, so I'm going to divide that out of each term. And what's left, I have a trinomial. This time the lead coefficient is 1, so I use the T-chart method. What multiplies to negative 12 and adds to negative 1, the coefficient of our B term. We're going to get negative 4 times 3. And this is the one where you get to just throw those numbers in the binomial. So we get x minus 4, x plus 3.